Hi, in this lesson I want to look at the analysis of very, very tiny minerals that we can find in rocks. We're working on page 12 of the Theme 3 booklet, and these techniques, sadly we can't do them in school, but they're really important, particularly looking for the rare and important minerals that we call the rare earth elements. They're essential for modern technology, yet they occur in tiny proportions within rocks. So we need a way of analysing rocks for their mineral content when we can't see what those minerals are. To do this, there's a couple of machines that get used. Firstly, we have a device called the electron microprobe. This is a tool that fires a beam of electrons at a sample of a mineral. That will emit X-rays from those minerals, and the wavelengths of the minerals that are emitted will be different depending on what mineral it is. So we can record those, and from that work out what's the composition of a small mineral, or what small minerals might be within a rock. And this gets down to even 100 parts per million, tiny, tiny proportions. To actually see what these minerals look like, we need to look at or use a device called a scanning electron microscope. This is a similar type of idea because it still fires a beam of electrons at a tiny sample of the mineral. The reflection of these beams then is detected, and that signal is used to make an image, a photograph of what can be seen. And we can see some incredibly fine detail within all sorts of geological structures. Okay, better than a nanometer. Okay, that's a billionth of a meter. So we can see really in detail what these things might be. An example of this is the image that you have on page 12. This shows a scanning electron microscope image of some very, very small crystals. You can see the scale there is 10 micrometers. That's 10 millionths of a meter. Or to put another way, 100th of a millimeter. Now, what I'd like you to do is I'd like you to work out the dimensions of that crystal that I've highlighted. Now, because of a printing error, one of the dimensions is missing off your booklet, dimension X, which I've highlighted there on the slide. Okay. Measure those, convert them using the scale, do any conversion before you start doing any calculations, and then work out the surface area and volume of that crystal. And also, can you work out what type of crystal it is? Okay, so press pause now, have a go at those questions on page 12, see what you can come up with. Okay, let's have a look at some answers. So this is our crystal that we were looking at. This is a cubic mineral. We've got crystal faces here all at 90 degrees to each other. Now, to work out its volume, we need to multiply the values of x, y, and z together. Now, I measured these and I reckon that x is about 16 microns, y is 23 microns, z is 11 microns. Multiply those together, we get 4,048 cubic microns. It's a tiny, tiny amount. Significantly less than 1 cubic millimeter. To work out the surface area, we need to work out the area of each of those crystal faces, and then we need to multiply those by 2 because being a cubic crystal, you're going to have 2 faces of the same area. Work through those sums using the same measurements. So I'm showing my work in, and we get an area of 1,594 square microns. The final question then asks you to identify this. If it's got metallic luster and it's cubic, from our list of minerals, it must be galena. Okay, these techniques are very high tech and very expensive. Something like £1 million for each one of these machines. And it's big research universities that have access to these machines. Cardiff University Geology Department, for example, has these. But even they hire out their machines to other universities that don't have them. They are an invaluable tool in analysing these tiny, tiny minerals that we can find within rocks. Now that's interesting geologically to find these things, but it's also crucial to be able to find these rare elements that we need for modern technology. We're going to find out more about that in the next test that you get. I'll see you then.